Good morning. So today we will discuss the histology of blood vessels. So we will try our best to cover arteries, veins, and lymphatic vessels. So the usual pattern of vessels is they have got three tunica and antemma, tunica antemma, tunica media, and tunica adventitia. So I am repeating again. There are three tunics of the blood vessel. One is tunica antemma, tunica media, and tunica adventitia. So the tunica antemma. So the tunica antemma is further classified into endothelial layer, subendothelial layer, and internal elastic lamina. I am repeating again. The tunica antemma is further classified into endothelial layer, subendothelium, and internal elastic lamina. So, what is endothelium? It is the simple squamous epithelium, and the loose connective tissue lies in the subendothelium, and internal elastic lamina is composed of elastic fibers. So, tunica antemma is composed of endothelium, subendothelium, and internal elastic lamina. Now, tunica media. The second layer from inwards to outward is tunica media. So tunica media is composed of smooth muscle fibers, and the outer layer of smooth muscle fibers is external elastic lamina. So tunica media is composed of smooth muscle fibers inwards, and from inwards to outwards there is external elastic lamina. So you see here, this is the tunica antemma. This is endothelial layer. This is subendothelial layer, and this one is the internal elastic lamina. I am repeating again. I told you that tunica intima is composed of endothelial layer, subendothelial layer, and internal elastic lamina. So this is the endothelium. This one is the subendothelial layer, and here this is the internal elastic lamina. Now then you see this is the tunica media. So tunica media is composed of the smooth muscle fibers arranged concentrically, not longitudinally. And the outer layer of the tunica media is the external elastic lamina. You see here, this is the external elastic lamina. Now, we discussed tunica antemma media, then we will discuss the tunica adventitia. So, tunica adventitia is composed of collagen and elastic fibers. Tunica adventitia is composed of collagen and elastic fibers, and they are arranged longitudinally. I told you the smooth muscle fibers in the tunica media, they are arranged concentrically. But here in the tunica adventitia, the collagen and elastic fibers, they are arranged longitudinally, and tunica adventitia is also supplied by the vessels and nerves. The vessels, but usually those vessels, the big vessels are supplied by the big arteries are supplied by the small vessels, and those vessels are called vasa vasorum. Those vessels are called vasa vasorum. The tunica adventitia is also supplied by the nerves, and those nerves are called nervi vasorum. Those nerves are called nervi vasorum, and they are usually unmyelinated nerve fibers. So I would combine, or I would repeat this again. The vessels, whether they are arteries or veins, they are they are composed of three layers: tunica intima, tunica media, and tunica adventitia. Then I told you that the tunica intima is composed of endothelial layer, subendothelium, and the internal elastic lamina. Tunica intima is composed of endothelial layer, subendothelial layer, and internal elastic lamina. While tunica media, it is composed of smooth muscle fibers, and from outwards, it is composed of the external elastic lamina. Tunica adventitia, they are composed of collagen and elastic fibers and supplied by the nerves and vessels. The nerves are called nervi vasorum and the vessels are called vasa vasorum. Usually the nerves which supply the big vessels are unmyelinated nerves. So these were the layers of the uh, vessels. Now, now we will classify arteries. Previously, we discussed only the layers of vessels. Now we will classify the arteries. So the arteries are classified into arterioles, medium-sized arteries, and large-sized arteries. Arteries are classified into arterioles, medium-sized arteries, and large-sized arteries. So, what is present in the arterioles? Usually, the size or the diameter of arterioles is 0.3 millimeter, and they are composed of all three tunica, which I discussed previously, but their size is less, and the systemic blood pressure is usually composed by the constriction or dilatation of arterioles. So I'm repeating again, arterioles are that their diameter is 0.3 millimeter in size. They are composed of all three tunics, and usually the systemic blood pressure is controlled by the constriction and dilatation of arterioles. Now, medium-sized arteries, they are bigger than the arterioles. The medium-sized arteries have got two other names, and they are distributing arteries and muscular arteries. So the medium-sized arteries can be also called distributing arteries, and it can be also called muscular arteries. It has also got all three tunica, but the tunica media is usually 40. Sometimes the tunica media can range, their range or their layers can reach up to 40 layers. So this is the one important point in the tunica media of the medium-sized artery, that the tunica media is usually very big and their layers can reach up to 40 layers. So the names of medium-sized arteries are They are also called distributing arteries, muscular arteries. All the three tunicas are present, but especially the tunica media, their layers can reach, their smooth muscle layers can reach up to 40 layers, and it is very thick. The examples of medium-sized arteries are brachial artery, femoral artery. These are medium-sized arteries. And the most important point in the medium-sized arteries is that their tunica media is very much developed. This is very much important. Now the large arteries. The other names of large arteries are elastic arteries and the conducting arteries. So large arteries can be also called elastic arteries and conducting arteries. They are called elastic arteries because elastin is present in high amount or in high quantities in the large arteries. They are called conducting arteries because they conduct blood to the different parts of body, and usually they are big vessels such as uh, aortic arch, thoracic aorta. These are the examples of the large size arteries. Their wall is usually thin as compared to the medium sized arteries, but it is composed of more of elastin. The one more important differentiating point in large arteries is that it is composed of all three tunica. All the three tunica are present in the large arteries, but they don't have internal and external elastic lamina. I already discussed that in the tunica intima there is internal elastic lamina, and in the tunica media there is external elastic lamina. But in large arteries there is no internal elastic lamina in tunica intima, and there is no external elastic lamina in tunica media. So this is the very most important point in the identification of the large arteries. The other thing is that their tunica media is composed mainly of elastin, which is very important. The tunica media is composed mainly of elastin. It is also composed of proteoglycans, glycoproteins, collagen, and smooth muscles. So I think we need to focus only on that the tunica media is composed of the elastin and the smooth muscle. Now, I would repeat this again that the large arteries, they are also called elastic arteries and conducting arteries. They are called elastic arteries because they are composed of elastin in abundant quantity. Their wall is relatively or comparatively thin as compared to medium-sized arteries. So, they don't have they don't have internal and external elastic lamina. The large arteries have got elastin and smooth muscles. The elastin is usually present in the form of fenestrations, and these fenestrations of elastin is called fenestrated lamellae. Now, what happens in the diastole? In the diastole, because of the elastic recoil of elastin, which is present in the large arteries, the blood pressure does not get very much reduced. So it is because of the elastin, the blood vessels usually retain the blood pressure because of the elastin muscle. So I would repeat the classification of the arteries again. We have got arterioles, medium sized arteries, and large sized arteries. So in arterioles, all the three tunicas are present, and usually the blood pressure, systemic blood pressure is composed by the constriction and dilatation of the arterioles. The medium sized arteries, They are also called distributing arteries and the muscular arteries. Muscular arteries, they are called muscular arteries because they have got a large amount of smooth muscle present in the tunica media. They have got all the three tunica, but the tunica media is very much developed because sometimes the tunica media is composed of 40 layers of smooth muscles. The examples of medium-sized arteries are brachial artery, femoral artery, radial artery, ulnar artery. Now, large arteries. The other name of large arteries are elastic arteries and conducting arteries. Their wall is relatively thin as compared to the wall of the muscular arteries. So one differentiating point, the muscular arteries wall is very much thick, while the wall of large arteries, they are not relatively thick. The other differentiating point of large arteries is that I told you that in tunica intima there is usually internal elastic lamina, and in tunica media there is external elastic lamina. In case of large arteries, there is no internal and external elastic lamina present in the tunica of large arteries. The other thing which is important is that in tunica intima there is elastin and smooth muscles. The elastins are present in the form of fenestrations, and these fenestrations are called fenestrated lamellae. So I think it is clear now. So should I proceed now? So up till now, we discussed only two things. One is that we discussed the layers of vessels, tunica intima, media, and tunica adventitia. And then we discussed the arteries and we classified the arteries. So in the classification, we classified the arteries into arterioles, medium-sized arteries, and large-sized arteries. Now we are discussing veins. In veins, all the three tunica are present in the veins, which I discussed earlier on. But these tunica are not clearly distinguished or demarked as compared to the arteries. The third thing is that their walls are thin and the lumen is large. I am repeating again. In the veins, all the three tunicas are present, but their tunica are not clearly distinguished. They have got thin walls and large lumen. The other differentiating point is that usually the veins have got more collagen but less smooth muscle and elastin as compared to the arteries. I am repeating again. The veins have got all the three tunicas, but their tunicas are not clearly distinguished as compared to the tunicas of the arteries. Their walls are thin and lumen is very much large. They have got collagen in abundant quantity, but less smooth muscle and elastin as compared to the smooth muscle and elastin of the arteries. Now, I will discuss the classification of the veins. So first of all, we need to discuss the post capillary venules. When the capillaries finish, then the venules are formed, and these venules are called post capillary venules. So in the post capillary venule, the inner layer is endothelium, and then there is parasite, and outside to endothelium and parasite there is the basement membrane. I am repeating again. The post capillary venule is composed of the endothelium, parasites, and outside to endothelium and parasites there is the common basement membrane. The other name of post capillary venule is parasitic venule because these are called parasites also. So this post capillary venule does not come in the classification of veins. So this is venule. Now we will classify veins. So veins are classified into muscular venules, medium sized veins, and large sized veins. The veins are classified into muscular venules or small veins, medium sized veins, and large sized veins. So the small vein, it is composed of all the three tunicas and their diameter is up to 1 millimeter. The most important thing here is the diameter. The muscular venules or small veins, they are composed of all the three tunicas and their diameter ranges up to the 10 or up to the 1 millimeter. In case of medium sized vein, their diameter reaches up to the 10 millimeter. It is composed of well developed tunica media. So if it is well developed tunica media, so it means it will be composed of endothelium, subendothelium, and internal elastic lamina. Then it is composed of tunica media, and usually the tunica adventitia is thicker than the tunica media and tunica intima. I would repeat this again. In medium sized vein, the most important thing is the size. So the size of the medium sized vein is up to 10 mm. The tunica is intima is very much developed as compared to tunica media and adventitia. So this is the one differentiating point. The other differentiating point is that the tunica adventitia is thicker than the rest of the tunica in the medium sized veins. Here if you see the large size vein, I already told you that the muscular venules or small vein, their diameter is up to 1 mm. The medium sized veins, their diameter is up to 10 mm. In case of large veins, their diameter is more than 10 mm. So this is the most important differentiating point in large veins. Now tunica intima, media adventitia, their characteristics are of the one and the same of the medium sized vein. I told you in the tunica in the medium sized veins that the tunica intima is developed. So here in large size vein, the tunica intima is properly developed. One important differentiating point. The other is that the tunica adventitia is thicker than the rest of the tunica, and this was the common thing in the medium size veins also. So if we differentiate between the medium size veins and large size veins, so the most important thing will be the size. The medium size vein is 10 mm up to 10 mm, while large size vein it is up to more than 10 mm. The rest tunicas, their the histology of the large and medium size vein is the same. Now, I would repeat this again. We classify the veins into small veins, medium sized veins, and large sized veins. The small veins are called muscle venules also. They are composed of all the three tunica, but their size is less. In case of medium size vein and large size vein, the medium size vein is up to 10 mm and large size vein is more than 10 mm. Their tunica intima is very much developed. Very much developed means they have got endothelium, subendothelium, and the internal elastic lamina. The tunica media and adventitia, in case of tunica media and adventitia, the tunica adventitia is thicker than the tunica intima and tunica media. And this is common in the large size vein also. So this was regarding the classification of veins. Now, before discussing the lymphatics and the lymph vessels, I think we need to discuss the capillaries, and then we will discuss the lymph. So up till now, we have discussed the histology of vessels, tunica intima, media, and tunica adventitia. Then we discussed the classification of arteries, and then we discussed the classification of veins. Now, and then we discussed the histology of post-capillary venule, and in the post-capillary venule, we discussed that the post-capillary venule is composed of the endothelium, pericyte, and it is surrounded by the common basement membrane. So this is the same histology is present in the capillary. Capillary is composed of endothelium and pericytes, and the endothelium and pericytes are surrounded by the common basement membrane. I would repeat again, the capillary is composed of the endothelium and pericytes, and they are surrounded by the common basement membrane. Now, pericytes. Pericytes are the contractile cells, and these cells are also called mural cells. They are composed of actin and myosin. Now, what are the functions of uh, uh, pericytes? The pericytes which are present in the capillary or the post-capillary venule, they causes the contraction and relaxation of the capillaries and post-capillary venules. So pericytes are the contractile cells. Their other name is the mural cells. They are composed of actin and myosin. Actin and myosin, and their function is that it causes the contraction and relaxation of the capillaries and post capillary venules. Now we will discuss the classification of capillaries. Capillaries can be classified into continuous capillaries, fenestrated capillaries, and discontinuous capillaries. Capillaries can be classified into continuous capillaries, fenestrated capillaries, and discontinuous capillaries. We classify capillaries on the basis of three important points. One is fenestrations, intercellular gaps, and the basement membrane. We classify the capillaries on three important things: fenestrations, intercellular gaps, and the basement membrane. The fenestrations are usually present inside the cell. You see here, if this is a cell, this bluish thing is the fenestration. Sorry, these pores are fenestration. This is the nuclei. These pores are the fenestrations. I would repeat again, we classify the capillaries into continuous fenestrated capillaries and discontinuous capillaries on the basis of fenestrations, intercellular gaps, and the basement membrane. So in case of continuous capillaries, there are no fenestrations. No fenestrations, the tight intercellular gaps, and the basement membrane is continuous. I would repeat again. I would repeat again that in continuous capillaries, there are no fenestrations, tight intercellular gaps, and the basement membrane is continuous. So you need to focus on these three important points. The examples of continuous capillaries, they are present in skin, muscles, lungs, and the central nervous system. The continuous capillaries, they are present in the skin, muscles, lungs, and the central nervous system. Now coming to the fenestrated capillaries. So we will see here, as the name shows, that in case of fenestrated capillaries, there are fenestrations or pores present in the cells. There are fenestrations or pores present in the cells. So, and these fenestrations or pores are covered by the diaphragm. So you just to focus on this thing, these fenestrations are covered by the diaphragm. But except the fenestrations, the intercellular gaps and basement membrane, there are tight intercellular gaps and continuous basement membrane. So I would repeat again. I told you in the continuous capillaries, there are no fenestrations, tight intercellular gaps, and the continuous basement membrane. Now, what happens in the fenestrated capillaries? In fenestrated capillaries, there are pores or fenestrations covered by the diaphragm. But the rest of it, there are no intercellular gaps and continuous basement membrane. So they have the same characteristics as that of the continuous capillaries. Just only fenestrations are added in the cells of simple squamous epithelium. Now, the examples of fenestrated capillaries, they are present in the glomeruli, intestinal villi, and majority of the endocrine glands. I would repeat again that the fenestrated capillaries, they are present in the glomeruli, villi, and the endocrine glands. So up till now, we are clear that in continuous capillaries, no fenestrations, and tight intercellular gaps and the continuous basement membrane. In case of fenestrated capillaries, there are fenestrations and tight intercellular gaps and continuous basement membrane. And these fenestrations are covered by the diaphragm. So this is important in case of MCQs. Now discontinuous capillaries. So we discussed the continuous capillaries, fenestrated capillaries. Now we are discussing the discontinuous capillaries. So we will focus on three things: fenestrations, intercellular gaps, and the basement membrane. In case of discontinuous capillaries, the fenestrations are present but not covered by the diaphragm, and large intercellular gaps and discontinuous membrane. The membrane is not continuous. In case of the fenestrated capillaries and continuous capillaries, the basement membrane is continuous. But here in the case of discontinuous capillaries, the basement membrane is not continuous. So three things: the fenestrations are present in discontinuous capillaries, wide intercellular gaps. You see here, wide intercellular gaps, and the basement membrane. The basement membrane is discontinuous. The other important point is that in case of fenestrations, the fenestrations which were present in the fenestrated capillaries, those fenestrations or pores were covered by the diaphragm or a membrane. But in case of discontinuous capillaries, those fenestrations are not covered by the diaphragm or a membrane. The examples of discontinuous capillaries are liver, spleen, bone marrow, and suprarenal glands. And in suprarenal gland, the important is medulla. In medulla of the suprarenal glands, there are discontinuous capillaries. So we have discussed a classification of, first of all, we discussed the capillaries, and then we discussed a classification of capillaries on the basis of gaps, fenestrations, and the continuity of the basement membrane. So we classified the capillaries into continuous capillaries, fenestrated, and fenestrations, and the continuity of the basement membrane. Now, as we know that the discontinuous capillaries, diameter is their diameter is large. Because their diameter is large, they are called the sinusoids. So if you will discuss it later on in the histology of liver and spleen, the discontinuous capillaries are called sinusoids. So this was all about the histology of the vessels. If you have any questions, just let me know. You see here, these are the clefts. And they are covered by the incomplete basement membrane. And the lecture is finished already. So if any questions, again, you can ask. Demarcation means they cannot be differentiated. So because in lymphatic system, there are lymphatic capillaries, lymphatic vessels, and lymphatic ducts. The lymphatic vessels are small in diameter, but they have got all the three tunicas, but they cannot be clearly differentiated or demarcated. We discussed this thing in the large arteries also. If you remember, we told you that all the three tunica cannot be clearly demarcated in the large arteries. And we discussed this same thing in the veins. Here in case of lymphatic vessels, the three tunicas cannot be clearly demarcated. In case of lymphatic duct, tunica intima is very much developed, while tunica media is thicker than the tunica intima and tunica adventitia in lymphatic duct. If you remember, in the veins, the tunica adventitia is thicker than the tunica media and tunica intima, while in lymphatic duct, the tunica media is thicker than the rest of the tunica. So you have to compare these things because they can come in MCQs. Difference between lymphatic vessels and lymphatic duct. First of all, the lymphatic vessels, their diameter is small as compared to duct, one thing. The other thing is that the tunica media is thicker than the tunica intima and adventitia. So this is not present in the lymphatic vessels. So you need to see it in the slides. Because they endothelium, they overlap. You see here, you see the endotheliums, the cells overlap over the other endothelium. They are not in continuity. And because of this overlapping, there is one-way mechanism, or the flame flows from one direction, only on one direction. Actually, the endothelium, they overlaps. The basement membranes, they are deficient. So you need to focus.